In this video I want to talk about pure substances, elements, molecules, chemical compounds, and different mixtures, homogeneous and heterogeneous mixtures. So what is a pure substance? A pure substance is something with a uniform and fixed composition at a microscopic level. Pure substances can be recognized by the unchanging nature of their properties. So it means that they are made up of only one component and its composition is invariant. It means that it doesn't change from one sample to another sample. Each of these substances is made up of only one component. And the components of a pure substance can be individual atoms or groups of atoms joined together, which are called molecules. We can classify pure substances in two classes, elements and compounds. So let's see what are the difference and what are the examples for elements and compounds. An element is a pure substance composed of only one kind of atom. An atom is the smallest particle of an element, and the atoms of different elements are different. For example, helium or helium element is made up of helium atoms. On the other hand, if a pure substance is not an element, it is a chemical compound. Chemical compounds are substances comprising atoms of two or more different elements joined together. So it means that a compound is a substance formed from two or more different elements in which the elements are always combined in the same fixed proportion by mass. For example, water consists of hydrogen and oxygen. Carbon dioxide contains carbon and oxygen. Molecule, the smallest chemical unit of a chemical or chemical compound that retains the composition and properties of a compound and can exist independently is called molecule. So we can say a molecule is the smallest entity having the same proportions of the constituent atoms as does the compounds as a whole. So it means that if we break down a chemical compound, the smallest entity is called molecule. For example, liquid water contains water molecules. Carbon dioxide gas contains carbon dioxide molecules. As we said, we sometimes have pure substances, sometimes we have different mixtures of substances. So a mixture is a substance composed of two or more components in proportions that can vary from one sample to another sample. And we can divide mixtures into two types, homogeneous mixtures and heterogeneous mixtures, depending on how uniformly the substances within them mix. Homogeneous mixtures, or sometimes they are called solutions. These homogeneous mixtures, they can be in gas phase, liquid phase, or solid phase. And homogeneous mixtures are uniform in composition. So it means that different samples of the same homogeneous mixture have the same composition. So what are the examples of solutions, or what are the examples of homogeneous mixtures? We can say clean air, which consists mostly of nitrogen and hydrogen, around 79% nitrogen, 21% oxygen. Or we can say some brass alloys, which are homogeneous mixtures, and they are containing elements of copper and zinc. So a homogeneous mixture has the same properties throughout the sample. We can separate different substances in a mixture by separation processes. So when a mixture is separated into its components, we call that separation, and the components are said to be purified. So with using processes or operations called separation or purification, we can separate different substances. So what are the heterogeneous mixtures? So heterogeneous mixtures are non-uniform in composition. So their non-uniform composition is clearly visible, like chocolate chip cookie. So they consist of two or more different regions. Sometimes they're called phases with different proportions. For example, wet sand is a heterogeneous mixture because the water content of wet sand can be different from one region to another region. So it basically the composition of substances in heterogeneous mixtures are changing from one region or one location to another location, and they do not have uniform composition. So the composition and physical properties change from one part to another part of the heterogeneous mixture. So soil is one example of heterogeneous mixture. Concrete is another example of heterogeneous mixture because the concentration of material is changing from one location to another location. So let's see this graph as a summary. If we divide this all matter to two branches, can it be separated by physical means? Yes. If it's yes, we have mixtures. If no, we have pure substances. Can it be decomposed by chemical process? If no, it means that we're dealing with element. If yes, we are dealing with compound. For example, water molecules. Here we are dealing with sulfur elements, for example. And on the other hand, we have mixture. Is it uniform throughout? If no, we call it heterogeneous mixture. If yes, we call it homogeneous mixture or solution.